Another day, another function. Today is 2.09, piecewise defined functions. Let's look at our goals. Just like every function we see, we're going to be graphing these. And what's really the heart and soul of piecewise defined functions are the rules. You'll see that very soon. And we're also, at the end of this, going to look at how we write an absolute value function, which you've just learned about, as a piecewise defined function. So what is a piecewise function? Well, it's also sometimes called a piecewise defined function, like you've heard me say. And really, it's a function where you're given specific rules about the function. And these rules, of course, affect the domain. So really what we're doing is we're chopping it up. We're breaking up uh, the line you see on the graph into several parts. Okay? We're taking pieces away. So you'll see that soon. But for now, let's take a look at these two functions you see in this box. Just looks like two different functions to me, right? And you're right. When it comes to writing piecewise defined functions, what you're going to find is we're going to see multiple functions put together in the brace. So basically, this is a shorthand way of writing this. Okay, so we're only going to write f of x once. So we write f of x equals a brace. So that is always the first thing you do when writing a piecewise function. Now, is this going to be a small brace? No, it's going to be a decent size, especially if you have more and more functions. Then this will stretch up and down to fit everything in there. So within the piecewise function, there are several different lines. Okay? So let's look at our first piecewise function here, f of x equals. Okay, for right now, I want you to please just ignore the rules. Okay, let's just focus on this first function. Okay, and think of it as f of x equals what you see there. How would you graph that? Well, by now you should be an expert at graphing straight lines. This is in slope-intercept form. So we put our y-intercept at 4 and our slope of -1. Connect the dots. There it is. So all is well, but there is a rule. So let's now bring that rule into place. And here's the rule. It says this is how we read this. This function exists in this scenario only if x values on that line are less than 0. So where is that? Well, on our graph, clearly x values less than 0 are over here. And for these points on this line, those x values are not 0, are they? So what we need to do is actually chop off that part of the graph and only keep that part. But did we do everything? You also have to look at the inequality sign. It is not or equal to because 0 is not less than 0. And right now, this solid dot tells us that's true, but we all know that's not. So what we need to do instead is put an open dot on the line where x is 0. So now this graph line fits this requirement. It has this function with this rule included. How do we do the next one then? Well, let's see. We're focused on now x over 2. And then we have our rule here. Let me just highlight that. Here we go. There we go. All right, how do we graph x over 2? Well, that's the same as 1x over 2, which is the same as 1/2 x. There's our slope. It was hiding a little bit. And what's the y-intercept? Well, there is no visible y-intercept, which means it's at y value of 0, right there at the origin. Okay, and the slope is rise over run, so up 1, right 2. We have 2 points. We can graph our line. And you guessed it, we have a rule we need to apply now. If x is greater than or equal to 0, greater than or equal to, so we know we are not including negative numbers, right? That's what this really says. Anytime you see greater than or equal to 0, that means only positive numbers, and 0 is included because of that or equals sign. And that's why you see the solid dot where x is 0, and it goes in the positive direction when it comes to x values. There it is, our graphed piecewise function. Okay, great. We were given the piecewise function. We made a graph. But I want to point out that these graphs don't always necessarily just have straight lines. We can have different types of functions, like a quadratic you see here. Can you answer this question? Why is this part of the parabola chopped off? Well, it's because of the rule, right? Which rule? This one, the rule associated with the quadratic. And of course, there's the linear line there, also with a rule. That's why we see that. Okay. So just know there can be different types of lines. It could be parabolas, straight lines, maybe something else. But I also want to remind you what the parent function of a quadratic looks like, because remember, this is really what we're looking at, right? Even though it is in a bit of a different format, but still you have your key points. So parent function of a parabola has vertex at the origin, key points at 1, 1, 2, 4, negative 1, 1, and we would have negative 2, 4 as well if that part wasn't chopped off. But can you take a graph and write the piecewise function? Try it. We know we start with f of x equals a brace, but how big? I see 1, 2, 3. There's a dot. I think there's something going on there. It's not a line, but something's going on. So I see 4. So I'm going to make this brace nice and big to fit everybody. Okay? And let's do a little color coordination here. So this first line, what would the equation of that line be if it was not chopped off? Well, it's a flat line, right? And f of x is the same as y. You've had a lot of practice, especially in unit 1 with these flat lines. So you could say y is equal to 3, because that's the value we see. Y will always be equal to 3 if what? What are the x values included? So we're going to write x. What's included? Is negative 1 included? Yeah, there's a solid dot right there. But does it go towards the negative or positive? Clearly towards the negative. So x is going to be less than or equal to negative 1. Those are the x values we see on this line. Okay, what about, let's do this one. That one's a little interesting. See if you can do it. So what's happening? Well, your x values over here aren't included and these aren't included, so they're really trapped inside, okay? Anytime that happens, you're going to have x trapped between two inequalities. Well, what are those values? You see -1 all the way to the left, and you see +1 all the way to the right. So where is our line? Well, it's values greater than -1, but also less than +1. They're trapped inside. Now, normally we come up with the function first, but I thought that was really important to focus on right now. Okay, what is the equation? Well, there is a y-intercept right at 0, so we're not going to see any value there. All we're going to have is our slope attached to x, right? Because remember, y equals mx plus b. Slope is always attached to x. Y-intercept is out here. What is the slope? Well, it's negative, right? As we go from left to right, we're going down. And what is that rise over run? We need to find two key points. Okay, here's a key point, there's a key point. We went down 2, right 1. Rise over run gives us -2x. -2 over 1, rise over run. What about the other straight line? I think we are pretty solid on those. How would you do that? Well, again, we need to identify two key points. Even though this isn't solid, that's okay. It's right where the hash lines intersect, and I see another point right there. So we go up 1, right 2, rise over run. That's the slope. Again, we're going to see this would have gone through the origin. So we're not going to need to identify any y-intercept. It'd just be +0, so we just don't write anything. And what's the rule this time? Well, it's always if, right? And if you're looking at a graph, I personally like to think of the word where. Usually you're going to see if, but I like where because we're talking about where on the graph is our line, right? Where is it? Well, x values greater than, not or equal to, because that is an open dot, 2. And finally, the dot. That one's a little interesting. What do we do with the dot? If you get this one right before you see me do it, you should feel pretty good about yourself. Really, what you're doing is you're describing where the dot is. Remember, f of x is y, right? So, what's the y value of that point? We didn't go up or down from the origin, did we? So it is 0 if, and here we always talk about x. What's happening with x? Well, it's equal to 2. That's it. All right. The time has come to write an absolute value function as a piecewise function. So, what do we do here? Well, you're really taking this one absolute value function and you're going to create a piecewise function. It's going to have two functions in it and two rules. Hopefully you remember why. And it's explained right here because absolute values always have a positive and a negative case. You've solved problems like this before, but here's a bit of logic to help it make sense. You could say absolute value of -2. Actually, I'm going to reword that. You could say I could get 2 by finding the absolute value of -2, but I could also find 2 by taking the absolute value of +2. Okay, and we see on our graph, we remember it's like this, right? It's a V, where you see your positive cases going up on the right, your negative cases going off to the left. Okay, so for the positive case, let's simplify what we see here. Simply take the terms outside of the absolute value lines. That's it. That's your function. That wasn't too hard, was it? But we still need to find the rule. And think about this carefully, since what's inside needs to be greater than or equal to 0 to be positive, we're going to take what's inside the absolute value sign, x minus 5, and we're going to set it greater than or equal to 0 because, like I said before, that means positive, right? Anytime you see something greater than or equal to 0, that means it must be positive. Okay? So we're going to take it out of the absolute value and set it greater than or equal to 0 and then solve for x. That's the rule. So you have your first function and your rule. Or yeah, first function and rule. We're going to come up with the second part to our piecewise function now, because remember, there is also a negative case. For the negative case, once again, take the x minus 5 out of the absolute value, or whatever happens to be inside. In this case, it's x minus 5, and multiply all terms by -1. That's your function. Of course, we need the rule. How do we find it? Similar to before. Before we said this has to be positive. Well, now we're saying x minus 5 is going to be negative, meaning less than 0. That's where the less than 0 comes from. And that's your rule. So we put that all together and we have our piecewise function. Look at that. We've successfully taken the absolute value function, applied those few bits of steps we went over, and now we have a piecewise function that will look the same way on a graph. And if you want to maybe visualize it graphically, let's do it for a second. Let's just draw a quick graph and graph this line. Well, you'd have a y-intercept of -5. I'm noticing some issues arising, so we're not going to graph that for now. You also are not going to be asked to graph that. So let's focus on a problem that takes what we've learned today, but applies it in a different way. So normally when you see find f of something, what does that mean? Plug it in, right? Just plug it in. Whatever you have, plug it in. But what do we do? Do we plug it in everywhere we see x in our functions? Does that sound good? I'm going to give you a clue. That's not what we do. So take another look at this piecewise function very carefully. Hopefully, you're noticing these rules. It says if x is less than 0, is x -6 less than 0? Yes. So this is the function we're plugging that value into. -6 is obviously not equal to 0, and it's definitely not greater than 0. Okay, so we take that -6 and we plug it in carefully to that first part of the piecewise function. cancel out, we get 4. Okay, try the next one. F of 12. Let's see. 12 is not less than 0, not equal to 0, definitely greater than 0. So we're taking the function that goes with it. F of 12, not negative. There we go. 2/3 times 12. 3 goes into 3 once. 12 4 times, we get 8. Okay, don't forget, you have to look at the rule before anything else. All right. We already went through this. So now it's time for our exit ticket. Actually, let's match a graph first. What's the graph of this piecewise function? Take a look at all the graphs. What do you think? Okay, f of x equals -1. That should be a flat line at -1. I see that everywhere. Okay, interesting. If x is less than -1, so my arrow should be going left. My goodness, all of these arrows are going left. So what do? They're all at -1. We look at which ones are an open dot because it's not or equal to. So D is out. Couldn't eliminate much. Actually, C is also out. Um, actually, I answered that in reverse. A and B are out because those have solid dots right here and right here. We need open dot. Now, what about our other function? It's an absolute value function. That's why you see this V shape on some of them. You might see half of it, like you see this line there. Okay, which one do you think it is? Well, the easiest thing to look at first is right here because we can see these all, oh, they're not all in the same place, but for C and D, they're different, right? They are different. So maybe we should graph this absolute value function, which you've done before. Okay, absolute value of x plus 1. That's all we have, right? Not many transformations. We just have dishonest h, meaning the vertex is where? It shifted to the left. It is now at -1. Do we see a vertex at -1 for C? No. It's at 0, -1 on the Y. We did not move down. There was no elevator V. There was only dishonest H. So looking at our winner here, D, we see vertex at -1 right there. It's hard to tell that's the vertex because this part of the line is missing. But process of elimination took us here, right? And let's just make sure the rule works. If x is greater than or equal to -1, yes. And now it's time for our exit ticket. Can you find f of -4 and 0 and f of 2? Well, not a whole lot of work here. Let's see how you did. 0 and negative. Hmm. Let's take a look. One thing at a time. Plug in -4. Where? Well, -4 is less than or equal to 0, right? Negative numbers. So is f of -4, well, that's just equal to what it is, right? -4. And what about f of 0? Well, this first function says if x is less than or equal to 0. This one doesn't say or equal to. So again, it's that value, -4. But for 2, that one's a little different, right? 2 is obviously a positive number, so that's greater than 0. So that is equal to 3. And that's piecewise defined functions.